Good morning. Today is March 22, 2020. And once again, this is Teacher Ariel. Our subject is measurements and experiments. Our topic for today is experiment on basic Ohm's law using analog multimeter in measuring electrical quantities. Let us now start. Objectives. At the end of this experiment, the student or students should be able to connect components according to schematic diagram, apply the skills in measuring current, voltage, and resistance, plot the data in a graph to visually compare the relationship of current, voltage, and resistance. Explain the relationship of current, voltage, and resistance according to the output experiment. And last, observe safety precautions in using tools and equipment in performing this experiment. What are the tools and equipment and materials needed? We need analog multimeter, we need regulated DC power supply, we need resistor ranging from 100 to 3K. We're going to use for at least 360 ohms resistor. Then breadboard, and the last one, connectors or wires. So we have here wires for connecting the circuit that we are going to do in this experiment. Here is the schematic diagram. So we will be using the DC power supply. Okay. So in this case, I have written here battery, but we are going to use a DC power supply. Then we will be using the analog multimeter to measure current, the resistor, and we have the voltmeter. Okay? So let us now start with the resistor. First, the color value, then the measured value. Okay. In this resistor, we have (360 ohms). So we have orange, then blue, then brown, and gold. So this is the colors of the resistor. So the color value is 360 ohms plus minus 5%. Now, let us measure the resistor. So, we will be using an ohmmeter to measure the resistance of the resistor. We will use times 10. Okay. First, we will connect the test probes together to make the pointer go to the zero on the right side of the scale plate. Now we are adjusting the 0 ohms adjusting knob to make it 0 in order for us to get the accurate measurement of the resistor. Then let us measure. So in this case, we have scale reading of 34, 30, 32, 34 times the range, which is times 10. So we have a reading of 340 ohms. Okay? Then we have here the table for our activity. I put voltages from 0 to 10 volts because we are going to vary the voltages. Then we have here the measured voltage from 0 to 10. Then we will be computing the current. And the last one will be the measured current. For resistor, we have the resistance of 360 ohms plus minus 5%, which is the color value, and we have 340 ohms, the resistance value, actual reading from an ohmmeter. So let us first set the power supply. So this is the power supply. So what we will do, we are going to measure first the voltage from 0 to 10. So as I explained on the previous videos on how to use this analog multimeter to measure DCB. Okay? So in this manner, we are going to set this multimeter to range 12 DC because we are going to measure DC voltages. So we will start from 1 volt. Okay? 1 volt. So let us measure 1 volt. So from positive test rod to the positive output of the power supply and negative to negative. So we will be using the scale of 12. So we have 0.2, 0.4, 0.6, 0.8, then 1. So we have here 1 volt. Okay? Next, 2 volt. Okay? Then we have a reading of 2 volt. Next, 3 volts. And we have the reading of 3 volts. Then next is 4 volts. Then we have the reading of 4 volts. Okay? Then next is 5 volts. And we have a reading of 5 volts. Next is 6 volts. And we have a reading of 6 volts also, followed by 7 volts. Also, we have a reading of a little bit more than 7 volts. Okay. Then Next is 8 volts. We have a reading of 8.1 volts. Next is 9 volts. And we have a reading of 9.2 here. 9.2 volts. Then the last one is 10 volts. And we have a reading of approximately 10.2 volts. So what we will do, we will put it on the okay, so we will put all the data in this table. So we have 0 volt, we have 1 volt, we have 2 volts. These are measured voltages from the power supply. So we have 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, and we measured a little bit near to 9.2 volts and 10.2 volts. So this is the voltage coming from the power supply, our indicator I mean, and this is the output voltage that we measured from an analog multimeter. Now let us proceed to the computation of current. In your lessons to your other teachers with fundamentals of electronics, your teacher had given you the formula of basic Ohm's law. Since we are going to compute for the current, we will use this formula. I is equal to V over R. Again, I is equal to V, which is voltage, divided by resistance. To compute for the current, I is current is equal to V for voltage divided by R, which is resistance. This is the formula that we're going to use. Okay, so first, let us compute. So eventually, we will have here 0 volt. 0 milliampere, sorry. Then here, we will compute for 1 divided by 360 ohms. 1 is 1 volt divided by 360 ohms. So, we have 2.77 milliampere. The next one is 2 divided by 360 ohms. 2 volts divided by 360 ohms. So we have 5.5 milliampere. On 3 volts, we have 8.3 milliampere. For 4 volts, we have 11.1 milliampere. For 5 volts, we have 13.8 milliampere. For 6, 16.6 milliampere. 7, 19.4 milliampere. 8, 22.2 milliampere. 9, 25 milliampere, and 10 is 27.7 milliampere. To make our presentation fast, I already computed this current using the formula that I have given you a while ago. Now, let us proceed to the construction of the circuit, wherein we have here the breadboard. Okay, we will use this diagram, schematic diagram. So we will have here the breadboard with a resistor of 360. Okay. Then we will connect it in a power supply. Going to negative. Then positive of the battery going to the circuit, positive. Okay, so we will measure now the current. So at first, our multimeter is off. Since we are going to measure the current, we will proceed. We will adjust the selector switch to 30 milliampere DCA. So we will use 30 milliampere DCA, and we will start from 0 volt. Okay, 0 volt. So eventually, if the voltage is 0, we will have 0 current also. 0 milliampere. Okay, measured. Then let us now start from 1 volt. Okay, so how we are going to connect this ammeter? We will connect this ammeter into the circuit. The positive test probe going to the positive terminal of the power supply, and the negative test probe, we will connect it to the resistor where the positive supply was connected here. Okay, now for 1 volt, we have a reading of approximately, so we are going to use the 300 scale. So this is 5, 10, 15, 20, 25, near 30. So we will approximately, this is 27, or 2.7 milliampere. So we will put the data on our table. 2.7 milliampere. Then I will put the voltage of 2 volts. Then we will measure the current. We have 50, 55, so we have 5.5 milliampere. 5.5 milliampere. Then I will set this to 3 volts. Okay, so voltage is 50, 55, 60, 65, 70, 75, 80. Okay, so we have 8 milliampere. Then 4 volts. So we have 4 volt, 100, 105, 110. So we have 11 milliampere. Then next is 5. Then we have 105, 10, 15, 20, 125, 130, 135. So we have 13.5 milliampere. Then 6 volts. So we have 150, 55, 60. So 16.4. We have 16.4 milliampere. It's near on 16.5. Then we have 7 volts. Our current is 19 milliampere. Next is 8 volts. Okay, so we have 22 milliampere. Then 9 volts. We have 24.5 milliampere. Okay, let us say 25. It's because it's near on 25. Then the last one we have 10 volts. Then we have 27.5 milliampere. So 250, 255, 60, 265, 270, 275. Since we are using 30 milliampere, so this is 27.5 milliampere. So our table is complete. We have the measured voltage, we have the measured resistance, we have the computed current, and lastly we have the measured current. Now let me present to you the graph of this activity. So I have here the graphing paper wherein horizontally the voltages are indicated below, and vertically we have the current indicated. So I have pre-marked the value of the current for this graphing paper. So we'll just draw a line. Okay? So this is your maximum current, which is 27.5, and this is the lowest, which is the 0. Okay, so in Ohm's law, it is proven in our activity. So by looking at this line or graph, it is proven that in Ohm's law, states that the electrical current flowing in a circuit is proportional to the voltage and inversely proportional to the resistance. Therefore, if the voltage is increased, the current will also increase provided that the resistance of the circuit does not change. In our activity, we use only one resistor, which is 360 ohms. We vary the voltages. That's why we also get the varied amount of current. The higher the voltage, the higher also the current. So when the voltage increase, the current also increase. Now, assignment for this activity. Try to answer this given problem. If a circuit has a resistance of 360 ohms and a current of 0.027 ampere or 27 milliampere, what is the voltage? You can just check the data in the video, or you can use the formula given to you to compute for the voltage. Please try to answer this this question. And the next question is, if a circuit has a resistance of 360 ohms and a voltage of 3 volt, what is the current? Again, you can find the answer in the table given to you in this video, or you can use the formula to compute for the current. Okay, so next week topic. Theory of series connection of resistor and experiments. This will be our next week topic. We are going to measure the total resistance using an analog multimeter. Thank you very much. Keep safe and study hard.